Okay, we're going to put that idea of breaking the weight force down into the perpendicular and parallel components into practice here on 3 situations. So in our first case, we have a 4.5 kilogram object on an incline at 36 degrees, so that's theta, and the kinetic force of friction is 19.5 newtons. So we're looking at, this is FFK, this is our mass, and this is the theta of the incline, which is also the angle that we're going to need to use to find the 2 components. Okay, so we're going to take the 36 of, let's find the weight first. So the force of gravity of the object, the mass being 4.5 kilograms. The force of gravity is going to be that. I'm just going to use 10 to keep life simple. So 4.5 times 10 is going to give us 45 newtons. Now, notice this is a grayed out already. This is not the force we're going to end up wanting. We're going to want the 2 forces that cooperate with the friction and the normal force. But this is 45. This one will be 45 newtons times the cosine of the angle that we have for the incline, which is 36 degrees. This one will be 45 newtons times the sine of 36 degrees. Okay. As long as your incline is less than 45, the perpendicular component, which is going to be equal to the normal component, is going to be greater than the parallel portion. So 45 times the sine of 36, this is 26.4 newtons. And then 45 times the cosine of 36 is 36.4 newtons. You can round that to 36. Either way, this is going to be equal to the force that's perpendicular. And then we want an acceleration in this case. So we know that the frictional force is 19.5 newtons. So to find the net force, we're going to take 26.4 and we're going to add to that a negative 19.5 since they're in opposite directions. 26.4 minus 19.5, we're at 6.9, just about 7 newtons. And again, the acceleration is going to be that net force, which is also the addition of all the forces, divided by the mass. Now be careful, it's not the weight. So it's going to be 6.9 newtons divided by the mass of 4.5 kilograms. And we get 1.5 meters per, we got the units here, so meters per second down the incline. Okay, in our next one, we're looking at a 65 kilogram crate, so that's our mass. The angle is inclined at 23, and we want a case of static equilibrium. We want the weight, we want the object to stay at rest. So the weight of the object, Fg, is going to be 65 times 10, or 650 newtons. The angle is 23 degrees. This is theta. So again, this is going to be the perpendicular component, is the cosine of 23. Again, we are in degrees. Just make sure you're in degree mode when you're making these calculations. Multiply by 650. That's 598. We're talking 3 significant figures there, so let's leave it at 598. And then the parallel section is going to be the sine of 23 degrees. And we're going to multiply that by the weight of 650. And we're talking 254 newtons. Now, if we're going to maintain rest, the forces have to be equal to 0 when we add them all together. We know the mass is 65 kilograms. If the net force is 0, by definition, the acceleration will be 0. They are directly proportional to each other. 0 means 0. That means that the 254 newtons down the incline has to be balanced by 254 newtons up the incline. And the perpendicular force of 598 has to be counterbalanced by the normal force of 598. Now notice that the normal force is less than the weight of gravity. Again, because we're at an angle, some of that force is redirected, and some of that gravitational force is heading down the incline. Again, notice that this force is grayed out. It doesn't count. We're using its two components, not the force that it's equal to. Okay, one more to go, and it's similar to the one we just did in that instead of being static equilibrium, it's going to be translational equilibrium. Now the 2.1 doesn't matter. What matters to us is that it's at constant speed. Therefore, again, all the forces must add up to 0. Our incline is 29.1 degrees. Our mass is 41.3 kilograms. So our weight is going to be 413 newtons, 441.3 times 10. We're using 29.1 degrees as our angle. And this is going to be 0. This is 41.3. That's our mass. This is theta. Our acceleration, again, is going to be 0. Again, the only difference between this and number 7 is we would classify this as translational equilibrium. The object is moving, but all the forces are still equal and opposite. The object is not moving because of the forces. It's moving because of its own property of inertia. All right, again, with the incline, the first thing you have to do is take this gray force and turn it into its two perpendicular forces. Again, for the perpendicular component, we're going to take the cosine of the angle, 29.1 degrees, and we're going to multiply that by the weight of 413, and we're around 3 significant figures, so we're at 361. For the parallel force, we're going to take the sine of 29.1, and we're going to multiply that by 413 newtons. We're going to round that to 3 significant figures, and we're looking at 201 newtons. Now, again, the net force has to add up to 0, so this force has to be counterbalanced by 361 newtons of normal force, and the 201 newtons of parallel force has to be counterbalanced by 201 newtons of friction to make this situation occur. If we hit a section of the incline where the friction was less, then we would start to accelerate up down the plane. If we hit a section where the friction was larger and therefore became larger than our driving parallel force, then it's not that we would move in the direction of the friction, but the object would start to slow down. And it might come to rest, at which point we'd be back to a balanced situation. Friction is one of those forces that tends to adjust itself based on the situation. It will provide just enough force to hold you in place until it can't provide enough anymore, and then you'll get the thing moving, and then the forces will be less for the moving object. The frictional forces will be less for the moving object than they would be for the stationary object in most situations. Okay, we're just going to wrap up with a tilted head trick. Just should recognize that if you take the paper in front of you and you just tilt it, you can take this object on an inclined surface and make it look to you like it's right back on a level surface, and we're right back to where we were before with what you may have thought were simpler situations. So just because the surface is tilted, don't think it's a huge impediment to your success. It just means you have to learn a couple of quick tricks, how to get rid of the uncooperative force, what to turn it into, tilt your head or tilt the paper and line everything back up, and you're right back where you started. Okay, so that does it for this episode.